Welcome back to another video by Adeptis Academy. Ever wonder how scientists predict hurricanes or how engineers test cars before they're built? The answer is computer simulations. Imagine a simulation as a digital twin of the real world, powered by the rules of physics and math. We use these digital models to safely explore what-if scenarios, without real-world risks or costs. Instead of building expensive prototypes, engineers can crash test a car or fly a plane in a virtual environment. This makes innovation faster, safer, and more affordable. Simulations let us experiment with ideas that would be too dangerous or impossible to try in reality. They help us understand complex systems like city traffic. By creating digital versions we can tweak and test. City planners, for example, use simulations to reduce traffic jams by experimenting with road closures or traffic light timing. Simulations are more than just programs. They're windows into possible futures. They power everything from medical device design to weather forecasts. By turning complex problems into digital puzzles, simulations help us build a better world, first inside a computer. They're essential to modern innovation, letting us push boundaries safely and efficiently. With simulations, our only limits are imagination and understanding. The world we live in is shaped by what we first build and test in the digital realm. So how do simulations actually work? It starts with modeling, breaking down a real system into manageable parts and describing them with math. These mathematical rules act as the simulation's instruction manual, telling the computer how things behave. Once the model is set, the computer calculates what happens over time, step by step. For example, a weather simulation tracks temperature, pressure, and wind at thousands of points, updating them every moment. This process repeats millions of times, creating a dynamic picture of the system. Powerful supercomputers handle these massive calculations, often filling entire rooms and running trillions of operations per second. The final step is visualization, turning raw data into graphs, charts, or 3D animations. This lets scientists and engineers see their virtual creations in action, from airflow over a wing to stress in a bridge. Visualization transforms numbers into insights, making the invisible visible. Simulations bridge the gap between theory and reality, helping us understand and improve the world. It's how we turn complex data into clear, actionable knowledge. In engineering, simulations are the invisible blueprints behind modern marvels. Before a car is built, engineers crash test it hundreds of times virtually, perfecting safety features long before the first real crash. Aerospace engineers use computational fluid dynamics to test thousands of wing designs, finding the most efficient shapes without ever entering a wind tunnel. Civil engineers rely on finite element analysis to break bridges into millions of digital pieces, spotting weak points and reinforcing them before construction begins. Even your smartphone's processor is designed with thermal simulations to prevent overheating. Simulations let engineers test and fail and improve without wasting materials or risking lives. They make it possible to design safer cars, stronger bridges, and more efficient planes, all in a digital playground. From skyscrapers to microchips, simulations are the secret tool behind the technology we use every day. They allow for rapid innovation, reducing costs and speeding up development. Virtual testing means fewer surprises and safer, better products. The future is built first in the digital world, where every idea can be tested before it becomes reality. Simulations are the foundation of modern engineering. They turn imagination into innovation. Simulations aren't just for engineers, they shape our daily lives in surprising ways. Every weather forecast you check is powered by massive atmospheric simulations, helping you plan your day. In medicine, simulations track disease outbreaks, speed up drug discovery, and let surgeons practice complex operations in virtual reality. Video games use physics simulations to create realistic worlds, from car crashes to weather effects. Financial analysts run simulations to predict market risks, while city planners design better transit systems using digital models. Ecologists use simulations to study climate change and protect endangered species. The same principles, model, test, predict, are at work everywhere, improving life behind the scenes. Simulations quietly power the systems we rely on every day. Building a simulation starts with a clear question. What problem are we trying to solve? Engineers define the goal, then create a mathematical model that captures the system's essential features. They translate real-world physics into equations, focusing on what matters most for the problem at hand. Next, programmers turn these equations into efficient computer code, building the simulation's software and user interface. Before trusting the results, simulations go through verification, checking the code for errors, and validation, comparing results to real-world data. Only verified and validated simulations are used to make decisions. This careful process ensures simulations are reliable tools, not just digital guesses. Every step, from defining the problem to testing the results, is crucial for accuracy. That's how simulations turn ideas into trusted virtual experiments. Simulations save massive amounts of time and money by replacing costly prototypes with virtual tests. Engineers can test hundreds of designs in the time it once took to build just one. Dangerous scenarios, like nuclear accidents or chemical spills, can be explored safely in a digital world. Simulations reveal details invisible in real tests, letting engineers see every millisecond of a crash or the flow of forces inside a structure. This deep insight leads to smarter, safer designs. Virtual experimentation encourages creativity. Engineers can try wild ideas without risk or expense. The freedom to fail digitally leads to real-world breakthroughs. Simulations accelerate innovation, making better products possible faster. They empower us to push boundaries and solve problems that once seemed impossible. With simulations, the only limit is how bold we're willing to imagine. That's why they're revolutionizing every field they touch. Simulations are powerful, but they're not perfect. Their accuracy depends on the quality of the data and models used. Bad input means bad output. Building reliable simulations requires deep expertise and careful attention to detail. High-accuracy simulations demand enormous computing power, often only available to large organizations. Simplifying reality is necessary, but it always introduces uncertainty. No model can capture every detail. Over-reliance on simulations can be risky. They predict possibilities, not certainties. Results must always be interpreted critically and validated with real-world experiments. Simulations are guides, not crystal balls. They supplement, not replace, physical testing and human judgment. The real world is complex, and every simulation has its limits. Used wisely, they're invaluable. But we must always remember their boundaries. They're one tool among many in the quest to understand and improve our world. The future of simulation is brighter than ever. As computers grow more powerful, simulations will become more detailed and accurate. Digital twins, real-time virtual copies of physical systems, will revolutionize industries, from aviation to medicine. Imagine doctors testing treatments on your digital self, or cities planning for climate change with virtual models. The fusion of simulation and artificial intelligence will unlock new breakthroughs, finding solutions we can't yet imagine. AI will help build better models and search for optimal designs automatically. Simulations will accelerate innovation, making our world safer, smarter, and more sustainable. They give us the power to ask, what if, and build a better future based on the answers. The world of tomorrow will be simulated first, ensuring progress is safe, efficient, and bold. With simulations, we're not just predicting the future, we're creating it.